Alright, what's up guys? It's Minx again. In today's video, we're going to draw the player. We're going to set up some basic physics and collision. So, um, it won't be too complicated, but it should be fairly simple. So, let's go ahead and get this ball rolling. So, we have kind of a couple options. I'm thinking we're probably going to end up having to do an interface for the update. Just, everything that it inherits for everything. Um, so I don't know. We'll see. 'Cause right now, what's gonna happen is we're gonna call because draw is gonna get called every frame, and then we're gonna call we're gonna update, which we're gonna make a public void update here on the player. We're gonna call update at the end of draw, which seems ridiculous. You know what? Fuck that. Let's call man, drawable input update. Yeah, let's call update. Add new item. Actually, yeah, we'll I don't know. I feel like adding it to iDrawable and changing iDrawable to something else makes more sense. So instead of having void draw void update, because these are all separate, we could say void update, and we don't have to pass through graphics window. We just call update and we just tell it to pass through. Um, and instead of calling this iDrawable, we could call it iDynamic. So dynamic object draws and moves and stuff like that. So we'll rename the drawable.cs. We're going to take this route, I think, because it makes more sense than making a bunch of interfaces with singular fucking things here. So we'll take draw and update. Then we got to fix some things. I know this has no issues, but it's going to pop up with some issues in a second here. So like, for example, if we go to player, it's not inputting iDrawable completely. Test object isn't either. And game window is referencing game window might be fixed. Nope. Okay, so let's update the game window first. iDynamic, and we'll call it dynamic objects, or we'll say OBJs. So iDynamic. Wow. We'll say iDynamic OBJ is fine. Copy that over. We gotta fix these methods too. I just don't want a bunch of dynamic objects. I just don't want a billion different interfaces when we only need a couple. The interfaces are already supposed to be, um, more than just what we got going on. So we'll remove. Input handler should still be its own thing because it's separate. It's not like a thing. And then this way, when we add something like late update, if we ever end up doing something like that, we can, it's iDynamic. I think that fixes all the issues at this point. Oh, all right, we gotta fix this. Let's say dynamic. We'll say the name is terrible, but dynamic OBJs is fine. And then we need to go into on update. So input should be handled first, right? Yeah, input should be handled first. Then for each iDynamic, dynamic, and dynamic objects, dynamic.update. So in here we'll call dynamic.update. So in our what is our technically our draw method, we call here we go, iDynamic drawable and dynamic objs. We'll call it obj. Call obj.draw. There we go. So that fixes all the issues in gamewindow.cs. Let's go back to test object and really quickly implement the interface. Oh, well, not iDrawable, iDynamic. And we have to implement interface. We're already implementing draw, so it's going to take that. It's going to implement update. We're going to comment out the or get rid of the throw exception, unused on this one. And what's actually really cool about this, well, never mind, it's not cool. Register drawable is still called register drawable, not registering drawable. So register dynamic object. Go. We go back to, there we go. Okay, so we had to fix all the variable names. Sorry, I didn't really go through explain it. We're just changing things to what they correctly are. So going back to test object, register dynamic object this. So then it'll register it, and then that's good. Unused on this object since it doesn't move. It's unfortunately it's not like Unity. I don't know, I guess I don't know how they like added it where it like, you don't add it, but it still technically works, but whatever. So update will technically get called every frame, but it won't do anything. If we have to, we can choose something like remove the update function or something from this by like separating it back out later. But I feel like dynamic makes more sense because anything dynamic needs to be drawn. Or if it doesn't need to be drawn for whatever reason, we can just not do anything with draw. Okay, so we've got that. Let's go over to player because player is also going to have this issue. We're going to say iDynamic instead of iDrawable. It's already implementing update and draw. We can actually get rid of the update call out of draw to fix that. So now I've got draw and update separate. So back to kind of where we started. Oh, got one error here. Oh, here we go. Register dynamic object. There we go. Okay. So let's go ahead and set up. So we want to draw the player first, and then we want to start worrying about things like collision and stuff like that and movement. So the first thing we want to do is set up the position, visual, and stuff like that. So thinking back to test object, we're going to do brush. We're going to call it visual. So like I said before in the first video, I believe it was, a lot of things inherit from brush, or inherit from brush. So like we have the solid color that we're going to use for now. There's textures and stuff like that. So what we're going to do is start with a solid brush, just going to be a solid color, and then we're going to later move on to textures, and we're going to use a texture map to do animations essentially. So we'll have animated player and everything like that. Very cool. So for now, we got visual. We're gonna have a let's see. Oh man, this is gonna get relatively ridiculous. So let's do vector 2. And we'll call it position. Vector 2 should automatically be added if it's not. So we're gonna do vector 2 position. Vector 2, we'll call it scale. Scale is annoying. It's our width and height. This is so we can do our rectangle. And we don't need to define a rectangle here. Yeah, we do. We'll do it. So we'll do a rectangle. I'll call it visual box. Actually, we'll say collision. Rectangle collider. Because we're gonna start colliding with things anyway, so we'll call it collider. That's fine. And for now, we'll set a movement speed. We'll say we'll be fine. Okay. So position scale collider. So we'll give this a region. Main vars. Hashtag end region. We'll do another region here. Region move vars, and we'll just end this region for now. So what this region is, so this region essentially clumps things down. So when you have like a billion things, you can hide them. We're gonna have like a good 10, 15 plus variables for movement, so we're gonna want that to be hidden. The other ones probably didn't need a region, but it is what it is. So position, scale, and collider. So by default, when the player gets created, technically we don't like let's see here. Oh, so okay. So the life cycle works is the player gets created. That doesn't necessarily mean they like have to exist yet. For example, they may not be like you load the level, you create the player. You could say create the player, and the player gets created at these exact locations. Or it's more like a player controller or no, I guess a pawn like an Unreal Engine, where you have the player controller, and this is technically the player controller. Um, and then you spawn the player, so you say you register the input, you register the dynamic, and that's where you have access. The controller controls the pawn at that point. So I think down the line it's going to be closer to what it is, but for now we're just going to do this stuff in the constructor. Um, and the constructor, it just calls all these things. So we're going to register those, and then we're going to set up some stuff. So next up, we're going to say this.visual equals new solid brush. So if we come here and do like brush, we can see, so we got brush, which is just the default. I think we can ignore that. Got brushes. I'm not exactly sure what brushes is. Brushes for all the standard colors. This class cannot be inherited. Okay, so solid brush is what we'll be using. There's also things like texture brush, and I'm not sure what hatch brush is. A rectangular brush with a hatch style. Foreground color and a background color. This class cannot be inherited. Not really sure what that is, but we'll use solid brush. Later, we'll likely be using texture brush. So solid brush, and we'll just use color.white to make it distinctive from the rest of the game, essentially. And then we're going to set up some quote unquote just a default spawn location. So we're going to move our test object down. So like, for example, its position is 100, 100. We're going to say 500, 500, and its scale can still be 100, 100. The player, on the other hand, we're going to set it up a little differently because right now it's just saying it doesn't even have the vectors yet. So this dot position dot x equals 100. This dot position dot y equals 100. And then this dot scale dot x. I like to do the scale x to be 50, and then this dot scale dot y equals 100. This is like a 2x1. For example, Minecraft, I believe, uses this. This will essentially be the setup for a character. And then when we go into like crouch, it might be like 50-50 or something like that. I'm not sure yet. But that's good for now. And we say this dot visual box. Actually, we don't need to set this up on create. We'll just call this on update. Because to be honest, well, this will be called in draw, not update. But to be honest, it's a little excessive to put it here. So we'll come down here and we'll say this dot visual box. Did I not call it visual box? What do I call it? I call it collider. This dot collider equals it equals a new rectangle, and in here we say this dot position x dot x, this dot position dot y, this dot scale dot x, this dot scale dot y. So we've got 4 things that need to be converted to an int. Let's go ahead and take care of that real quick. And let me move this over. I can't see. So remember, parenthesis, int for an explicit cast. That tells the engine that we are good with losing this certain information if it happens. So this dot collider equals new rectangle. So it'll update the collider every draw frame. The collider, I might end up changing over to update. Update's called before, no, update's called after draw. What we're gonna do is actually we are gonna put this here, but we're also gonna put it here. So the reason I put it in update is because of everything that happens. So technically, draw gets called before update, but there's at least one scenario where draw where collider is technically defined as like 0, 0, 0, 0. So collision might act a little wonky. So if we put this here, then by the time draw gets called, it'll already have told the collider the correct information. And then, so when draw draws, it'll draw correctly from the first frame, and then update will update it. So it'll update after. So this is good. Unfortunately, put it in there twice. That's annoying, but that's okay. So, next up, we got, let's see here. We actually have to draw, so we'll go ahead and say window dot fill rectangle, and it's this dot visual and this dot collider, so it already knows. And at that point, we should have a white box at 100, 100 that is a 50 by 100 rectangle. Let's start. Hopefully we don't get any issues. All right, looks good. So we still got our movement control, jumping, So next up is, do we do collision or physics first? I think we do collision first because we have the two boxes here, so we can add a collision reference. So let me do this. Simple AABB collision. So let me bring this over. This is like super like standard, like it's not hard. So this looks to be system.out.println. I'm pretty sure that's Java. That's gross. .net. Anyway, so we see it's we have player 1.x minus less than player 2.x plus the width, and this is good. So this will tell us. So we can use this as an example to check to see whether we're colliding with something. So let's close out of this. We're not going to look at it too much. Now, there's a couple different places we could handle collision. So, for example, we could handle collision right on the player, and right now only look for player collision. We could try to handle collision at the game window level, where we say handle collision object 1, object 2, then say for each collider object, check for collision. I think that's a little excessive in my opinion. So for now, we're going to implement it on the player and check for player collision. And then maybe on other things, we may just re-add it or make it a interface or something like that. But for now, we'll just go ahead and toss it on the player. So let's go ahead and put it down here. It's not too bad. It's a little different than that. Right here. So we're going to do it a little differently. So the way they did it, oh, I got rid of it. That's okay. Is they didn't they only printed something out if it were true. They didn't really return anything. So what we're going to do is we're going to make a private bool and call it check collision. And it's going to take two inputs. It's going to take a rectangle, obj1, and all right, well, we're gonna leave it with one input for now, and we're gonna have to come back to this in a second. So technically, obj1 is almost definitely always gonna be the player. We might not even we'll leave it like that because it's gonna use our collision rectangle. But what we want to do is say here. Let's go to interfaces. I was thinking also adding this to dynamic because we don't have to like do anything else crazy. We could say was an interface, was it not? Okay, I did do it as an interface, but I didn't add it. Cancel that. So, yeah, we got position and scale as an interface. It makes sense to be added to dynamic, so we're gonna go ahead and try it. So vector2 position, and we're gonna give it only get. We don't need to set it for this. I don't even know if we probably could, but we don't need to. Vector2 scale and get. We only need to get these. No one else needs to know about them, or no one else needs to be able to change them through this. It just needs to be gotten. Let's go back up because now we're missing something. So if we right click on dynamic, we need to implement the interface. So right now it's going to go directly to throw new not implemented. That's okay. So what we can do is actually get rid of this. And actually we can even get rid of this and say vector2 idynamic.position. Inside these little things, the get is the action points to position. Gotta close it off. So instead of like saying we implement position and our position is the interface position, the interface just points towards a variable that we use on the player. So we don't actually have to do anything else other than point at it. That makes things a little easier for us. So we can say get, we'll say this dot scale and this dot position just to be a little safe. I don't think it matters that much. I think it's implicit that it does that, but So vector2iDynamic.position is equal to, essentially the get will point towards this dot position. That way, if something else were to try and collide with something that is a collidable or a dynamic object, it'll say, okay, you can collide with this object at this position and scale, so you know exactly where it is. We might even add the collide to the dynamic. But let's go to the test object real quick and do the same thing. Initial fix. Doesn't matter. I don't want to. Oh man, it's going to be annoying. That's okay. Yeah, we can actually just go back to player. I think we can just copy these over. Is it not the same? Position and scale, right? Get over here. Go. And let me actually put these up here. Did they put that down there on the player? No, why the heck did they put it so far down on the fucking other thing? Let's see, we got an error here. I code paths for well. Okay, so back to the change collision, or check collision. So object one, and then we need an iCollision object. Or not an iCollision, excuse me, an iDynamic. I was thinking iDynamic object, obj, we'll call it obj2, or we could say collider or something, I don't know. Obj2 is fine. Okay, so now going back to the what it wanted us to check for. So if obj1. Now the reason I did rectangle for obj1 is we have exact access to the x and the y and the scale. We don't have to like or the width and the height. We don't have to like say dot position dot x anything. Unfortunately, with obj2, we have to say obj2 dot scale or dot position or whatever dot position dot x plus obj2 dot scale. Oops, the heck. Scale dot x. Gosh dang it, tabbed out. And we're just gonna go with pretty much the exact example. Obj1 dot x plus obj1 dot width greater than obj2 position dot x, and my favorite part of this, obj1 dot y is less than obj2 dot position dot y plus obj2 dot scale dot y. And give me the space here because that's annoying. And one more line, I promise. obj1.y plus obj1.height is greater than obj2.position.y. Pretty straightforward. Get out of here. What's your problem? Oh, I'm missing something here. Oh, I forgot the and here. My bad. There we go. Oops, no. Go. You bastard. I'm trying to fix this so everything's aligned. There we go. And we tab all these in once. Very nice. Okay. So, if all of these things are, if any of these things are true, or I guess if all of them are true, then we return true. And then else, return false. Oh, pretty straightforward. So, the way I did this for now, at least, see, it's funny. I don't want to start doing the for now we're going to do it this way, then later we're going to change it. I really hate that. Though for this, it's because it starts to get ridiculous if we start checking collision on everything when there's only one thing we're worried about colliding with right now. The only thing we're worried about colliding is the player and something else. So what we can do is use this to just handle it. So we go to the player, we go back here. Instead of using a discard for the player, we're going to make a reference to the player to the game. The player is important enough where I am comfortable doing this. We could say private player. We'd say player. It's perfectly fine. And then player equals new player. This. So now we have a reference to the player. And then on update, we could call say dynamic.update and player.check collision. Oh, it's private, is it not? Make it public. Is that really how I did that? I feel like that's wrong. No, we didn't do it here. Okay, no, this is good. Okay, I was about to lose my mind. I'm like, what? No, okay. We did not do it in the game window. That's gross. It's icky anyway. Um, what we do is we actually take a list of all the dynamic objects. Collision in game.colliders. Right, yeah, we do a collider section. We use dynamic. I'm curious though, because the player is not a collider, the player is dynamic. Am I really gonna have to change this? Oh man. So the player is dynamic. That is a truth. We may just have to do an if check for if it is the same player, because the player is technically like the player's collision is colliding with itself technically if you check the collision of the same coordinates, because that's all it passes through as coordinates technically. It will always return true that it's colliding, so it's kind of bullshit. Well, not really bullshit, it just makes sense, but we'll see. Okay, so ignore me. I just had to go through a thought process here. So let's move on and actually make our collision. So I didn't actually show how collision is going to work. It's actually fairly cool, I guess you could say. And this video is probably going to be a bit longer as a result. Yeah, we're at 26 minutes. I apologize. So we'll make this as brief as possible. We have a cube. You have a wall, and the cube is going towards the wall. So what happens is you want to check. You want to say, all right, cube's not colliding, so it's good. Oh, I know, X bad, or X bad, X good. In this case, it is colliding. That's a little far in, but you get the idea. So how do we do that? So what we do is we make so we have our cube, and our X movement is, let's say our X plus equals, oops, 5. So it's going to move over 5. So what happens is if we're here and the distance between these two is 5, so what we do is we have a little collider here. So it says, well, this is a little disingenuous. We have a cube, and then we have a second cube that is 5 wide, because that's how much we're moving. It's not static, it's dynamic, it's based on how much we move. It says, is this colliding with this? Yes. We move closer and closer until it hits 0, then our position is equal to that, and we're set. It won't allow us to move anymore. So that's how it works. It will check to see how much we're moving, and it has a fake or a false collider, and it will collide with it, and then say, all right, you got to stop your movement here, and then it will stop it. It'll say movement's equal to 0. So that's how that works. So let's close out of this. Let's go ahead and start this process up. So first we have to make the false colliders. So we need 2, one for horizontal and one for vertical. So if we go rectangle, horizontal, we'll say H collision because it's easier, equals new rectangle. And just like the other stuff, we can actually open it up with brackets instead of having to set up those the other way, because this is just easier to read. So since this is our horizontal collider, so width and height are always equal to the width and height. So it's not this dot position x, it's this dot scale. Height equals this dot scale dot y. It's smart. Now x is the only difference here. So x equals and to this dot position dot x. However, we need a second variable. We'll add change in x, or add expected change in x. We'll talk about that in a second. Then y equals this dot position dot y. And we're gonna do the same thing for we're gonna do a v collision. Say v collision. new rectangle. And instead of adding expected change in x, we're going to move this over to add expected change in y. So I called it something else, and I regret calling it something else previously, so I'm going to not call it something else this time. So we're going to say vector2 speed. So speed is our expected change, essentially. How much do we expect to move this frame? Because what will happen is at the end, we can actually add this now. We can go all the way towards the end. This dot position dot x plus equals this dot speed dot x. And actually, I think we can say this dot position plus equals this dot speed, because it'll add the x to the x and add the y to the y, if I'm not mistaken. Let me just double check. C#. What if you add two vectors? Let's see. $30 to 35. Yep. Okay. So it does exactly what we say. So if we add a position, so the XY position gets adds XY as speed. So X gets added to X and Y gets added to Y. So we can just do this dot position plus equals this dot speed. Even though they'll be identified separately throughout, that helps. So that's all we do. And essentially what we say, if we are colliding, we're going to get ourselves up to the point where we are fully colliding with our actual object instead of our example collider, and then we're going to stop moving speed. We're going to set speed to 0 essentially at that point. So let's go ahead and move through that. So this is a little interesting, and it'll be a little goofy to look at. So for each, I don't know, we haven't done movement yet. Movement's next. I dynamic and obj and game dot, oh man, dynamic. Okay, we're gonna make dynamic objects accessible because we need it. We need something to check our make it public. We need something to check our collision against, and it happens to need to be dynamic objects. So if we go back to player and game dot dynamic objects. So this is where we're going to say if obj equals this, we're going to continue. So this will skip through it. What a continue does in a for each loop is, I don't think it's going to tell me there by hovering over it. C# continue. Here we go. So these are loop things. Where's the continue? So the continue statement breaks one iteration in the loop if a specified condition occurs and continues with the next iteration of the loop. This example skips the value of 4. So we're going to use this to skip ourselves. Otherwise, what we're going to do is say if this dot check collision. I don't know why that's whatever. So if this checks collision, and we want to check our horizontal, not horizontal alignment, I said H collision, against collider, or against obj. So we're saying if this is true, so if we are colliding, and this is where it gets weird, while, and I'm going to toss the same shit in there, while we are colliding, our H collision dot X minus equals math dot sign this dot speed dot X. So, and then after, if we break out of the while loop, we say this dot position dot X equals horizontal collision, H collision dot X, and this dot speed dot X equals 0. So let's go through this real quick because this is goofy. This looks weird. I know, believe me. So the way it works is So it checks the collision of our horizontal collision, checking our collision on that next frame, essentially. It's going to say, next frame, based on the speed that you're going, are you going to be colliding with this object? If yes, it's going to start, it immediately goes into the while loop. You could basically just ignore that the while loop is like a separate from the if. Immediately goes in and it says, okay, we're going to subtract the math.sign, which is either just a negative one or positive one, from the collision.x and say get closer and closer to the object until it hits it. And once it hits it, it's like, okay, we're not colliding with it anymore. We are aligned with it. Set our position to that collision and set our speed to 0 and stop moving. So that's it for horizontal. Now, if we were to try and go vertical right now, it would break. So we need to write our vertical. It's pretty much the same thing. In fact, why don't we just copy this and change it over, or do that. So we're gonna do this and say, let's see, we need to loop through this twice. Why don't we just do actually, let's get rid of this. And I don't know if this is gonna work, but we're gonna try it out. So let's see. All right, so we'll do a V collision, and we'll just change all H collisions over to V collision. And then change all the X's over to Y's. V collision.Y. This dot speed.Y. This dot position.X. V collision.Y. I mean this dot position.Y. This dot V or V collision.Y. And this dot speed.Y. Okay, so we've got all this set up. They're both in the same for each loop, so we don't have to go through them twice. I expect it to be faster. Not that we're too worried about performance yet, but if we need to, we can break this out of the for each loop into its own. I had it originally written out in 2 separate for each loops, but going through them twice, especially with the extra if check for if it's equal to this. So that's good. The next thing we want to do is actually tell our player to move. So let's see, we got it. So this is where order of operations matter. So our order of operations right now is, let's see. So if we go back to the game window, mode game loop on update. So it handles our input first, and oops, it handles our input and then it calls update. So that means we can say, that's actually good. So we can say move right or move left. For now, we can this dot speed dot x equals, we could say -5 for move left. Move right, we can say this dot speed equals 5, and we're gonna say, I'm gonna change this to S. I'm gonna, or jump, I'm gonna say drop for now. I'm gonna make a private void drop. And the reason for this is we don't have like gravity or anything at the moment, so jumping is kind of pointless. Well, we need to be able to go down to check collision. So we say this dot speed dot y is equal to -5, and I will talk about that in a second. And for drop, it'll be +5. So the way the canvas works is it starts in the top left. So if you go down, you're increasing your y, so 0 to, technically it's 0 and 1080 on my screen. So if you're dropping, you want to add, and if you're going up, you want to subtract. So doing the like vertical stuff like gravity and jumping is a little goofy. So actually, since we're already drawing the player, theoretically we should be able to move, unless we have errors. It's not fast. Okay, so there's a little bit of an issue because we don't have anything that's telling us to stop moving, which is like a drag coefficient. But we should be able to. Okay, so we got a little bit of a goofy thing going on there. What's going on there? Okay, collision's acting a little weird. I'm gonna try and fix that. I'm gonna break these out of this for each loop. So for each iDynamic. That's probably why. I don't remember why I did it in a separate one, but that's probably it. And we're gonna toss the same if check here because we don't want to check against ourselves. Let's go ahead and check it out again. Oh, not moving at all. Did I do something wrong? If object is equal to this, we continue. Oh, I pulled it out of the X and it was colliding with itself. Excuse me. There we go. I didn't mean to cut it. I meant to. God. Okay. It's okay. So it has nothing to do with the. It may have something to do with the angle we're coming in at, because right now we're coming in at a harsh angle. So let's fix the movement issue. So what we can do is say this dot speed times equals and we're gonna do a this dot drag or this dot friction, and we're gonna come up into our movement variables, and this is gonna be our first one. This is gonna be a float. Float friction equals 0.8f, and this will allow us to say, hey, stop going so fast. So if we like move, it slows it down. So let's go ahead and try and collide with this. Okay, so it's still acting a little goofy. Why is that? So okay, so if we go down, it's going around the object. That is interesting. That's honestly unexpected. Why is that? All right, we got to do a little bit of debugging here. Oh, I know why. We forgot to do this, and it's actually probably not an issue with this at all. So what it's doing is it's not checking against. Well, okay, the rectangle is equal to our rectangle. I forgot to put this into the rectangle definitions when we created these. So let's say plus this dot speed dot x, and that is an int as well. In fact, we could put these in, we could do this and then cast in front of the entire thing. Go. And we'll do the same thing over on y, so we'll get rid of this. Plus this dot speed dot y, and cast the result to an integer. So I'm actually going to go ahead and put the y collision back inside of the x collision, just to see if it works, because I kind of want these to be in the same for each loop. I don't want it to be checking twice. It's not Santa Claus, it doesn't need to. So come down here. Cool. All right. That was the mistake. That's my bad. A little bit of an oversight. So collision's very strong. I'm pretty certain there's a very specific edge case. It's like really hard to achieve like this. I don't even know if it's possible to achieve in this case. I know down the road when we start implementing like crouching and stuff, there's like an edge case with these fucking corners, because these things are AIDS, dude. That make it really difficult to deal with. But we'll cross that bridge when we get there. Let's get out of this. So we've got movement. We've got collision. I know this video is already super long. I apologize. This is 43 minutes. This is longer than the first one. Guess I shouldn't have done actual movement and collision. So this is kind of annoying. We're gonna get rid of this stuff later. I know. I think I didn't do that for anything else, so I'm okay with having it for that. Because everything else is pretty much adding or acting as intended. The only other thing I want to do is do gravity real quick. That's the last thing. So let's make test object. What's gonna fix it? We're gonna make it a floor. So position. So thinking this is we have a 1280 by 720. So we'll make this 670, and then it'll be at, so that's 0x 670y, and it'll be 1280 width, and 100 is fine. We'll do 50 to be super efficient. So that'll go across the floor, and then what we'll do is go over to the player, say float gravity equals, oh man, I don't even know what a good gravity value is. We'll say 5F, sure. Yeah, that's fine. So we'll do, and we'll just apply gravity right at the beginning for no real good reason. This dot speed dot y plus equals this dot gravity. Go. There we go. Can't really jump or anything right now, but we get the picture. We can kind of move around. We went over the edge. We'd probably fall if I'm not mistaken. Yep, there we go. All right. So we've got gravity, which is not very good. We don't really jump, but we move. We have collision. And we can use this collision for other stuff. So right now it's fairly hard coded to check for like colliding with a dynamic object. We may change this for like checking for like wall collision this way, and then checking for like dynamic collision, so like a dynamic object being a enemy as opposed to a thing. So we say check collision, each collision object implements iDynamic. We could say iDynamic.collide instead of whatever the fuck we're doing here. So good alternative. But for now, we've got basic collision and physics set up. So in the next video, we're gonna fix up our. We're probably gonna fix up our physics here, add jumping and stuff like that. And then I'm not sure if we're gonna go into the level designer or if we start like adding like a player visuals or something like that. We'll see. But anyway, thank you for watching and have a wonderful day.